Welcome everyone to this lecture on the topic on the chapter laws of motion. We are going to continue with our questions which we are doing in the last video. And those were the questions which involved some primitive application of the laws of motion and basically learning how we try to apply the idea of F equal to ma in different cases. So what we observed was that when we are uh, thinking about writing the equations, then it is convenient to write the equations in one by one manner. And that is first write the equation in x-axis and then write the equation in y-axis. So let us begin. So the first example which we are going to take is and this question. So you have to write and draw the normal force and other forces acting on the block sliding down a smooth incline. So there is a block which is kept on a smooth incline. Let us draw this line. So this is the incline and it is given to us as smooth, and we are supposed to draw the normal force and other forces. So what are the forces acting on this block if we are thinking about writing on the forces? So the forces acting on the block would be the weight of the block. That would be the one force which we should write at least. So one force can be the weight of the block. And the normal force on the block. And should we write the friction force on the block? So since the incline is smooth, there would be no friction acting on the block. So only two forces are sufficient. Or actually all that are acting on the block. So these are two forces. Next, let us draw the normal forces acting on the block. So let us draw this incline. So this is our block. So we know that the normal force acts along the common normal. So this is our common normal. Normal force would act on the block in this direction, that is away from the surface, and the weight of the block would act at its center of mass in vertical downward direction. And that would be the weight. We are given the angle of inclination as theta. So this particular angle is theta. This angle is theta. So we can draw a triangle. This is the perpendicular. So this is a triangle which we are talking about. We are given this particular angle as theta, this angle as 90. So this angle would be 90 minus theta. And since this complete angle is 90, this angle would be theta. Since this particular angle is 90, this is 90 minus theta. So this angle should be theta. So the angle which the weight makes with the normal acting or the common normal between the surface and the block, the angle which the weight makes with the common normal is the angle theta. So as you can see, there is no force which is preventing or which is going to prevent the downward motion or the impending, as we like to say, the impending downward motion of the block, as the block may or may not have started moving along the incline. It must have started from rest, so it is not moving yet. So it is going to move in some forward time, but for now it has some acceleration along the incline, which we have marked in the figure. So what we are saying, that there is no force which is going to prevent this acceleration of the block in the downward direction. And would the block move perpendicular to the incline? So the answer is no. Natural observations show us that there is no spontaneous motion of the block perpendicular to the incline, only along the incline. So we'll be taking the component of weight forces or the component of normal reaction as per our convenience. So always in doing such kind of questions, that when there is a block and there is an incline, or there are more than blocks kept on an incline, so what we have to embrace, or what we have to learn is that we have to take the axis along the incline and perpendicular to the incline. And this is because the reason which we discussed in the previous video, that when we are taking the axis along the acceleration and the other axis perpendicular to the direction in which acceleration is happening, this gives us an advantage. And the advantage is that one of the axes will at least balance out, or it would have no acceleration. So at least the RHS of the equation would have no value, or would have a value equal to 0. So let us see what happens here. So we'll be writing our equation, sum of forces along x-axis, that is equal to mass times acceleration, and sum of forces acting along y direction, that is mass times acceleration y direction. So W sine theta, that is the weight of that is the component of the force acting along the x-axis. And how did we find that? We can take the component of weight. One component of weight is perpendicular acting along the incline, that is W sine theta, and one component of weight is acting perpendicular to the incline, that is W cos theta. So W sine theta is acting along the x-axis, it is equal to MAX. And similarly, and from this we can say that the acceleration along x-axis is simply the weight of the block sine theta divided by mass. Weight of the block can be written as mg, so mg sine theta divided by the mass. So this gives us the acceleration of the block along the incline. So this was not the objective of our question. Our objective of the question was to write the forces on the incline, write the forces acting on the block. So we wrote the forces, weight of the block and the normal force on the block. So again, who is exerting this weight of the block? The weight of the block is being exerted by the earth. So as you can see, it is written here, weight of the block. So it is exerted by the earth, and the normal force on the block, it is exerted by the incline. So here we have found the acceleration of the block. Acceleration of the block is g sine theta, and the two forces are this. So that means that whenever a block is kept on a smooth incline, then its acceleration on that incline is simply g times sine theta, where theta is the angle of inclination. And that gives us the acceleration. And what we already also notice is that the acceleration of the block is independent of the mass of the block. That is also a very good fact. And this is just like saying that when two balls are dropped on earth, then they reach the ground surface, and they are dropped from the same height. They reach the ground at same time. This is because the acceleration of both the balls are independent of its mass. In the same way, when they are kept on incline, the acceleration of the block is independent of its mass. So this means that it's not what we naturally think is that the heavier block would reach the bottom of the incline at a slower rate, or the smaller block would reach the bottom of the incline at a faster rate. In a smooth incline case, both the blocks will reach in the same time. So next, let us do a question. So the next question which we have is a block is kept on a smooth incline as shown in the figure. Again, just like a case which we just did, and it is connected to a thin light string whose other end is tied to the ceiling. We have to draw all the forces acting on the block. So this is our objective. So the normal force and the weight of the block that we have already drawn, just like in the previous case. And in addition to that, one extra force, that is the tension force, would start acting also on the block. So let us try to find them. Although the question only stated that you have to draw all the forces acting on the block, we have drawn all the forces: the weight force, the normal force, and the tension force. But what are these values? So, like we did in the previous question, we will be taking the components of weight along the x-axis and along the incline and perpendicular incline. So, along the incline, the direction which we have is x, and perpendicular to the incline, the direction which we have is y. So, the component of weight uh, along the incline. So, let's say this angle is some theta. So, the component of weight along the incline, that would be w sine theta, and the component of weight along this common normal, so that would be along the side in which theta is there, would be w cos theta. So again, writing the equations, sum of forces along x-axis is equal to mass times acceleration. X-axis is along the incline. We have taken component of weight, and this is very important to actually learn. We can take a moment or two to again learn how the component of weight is divided. First, we know that the angle which the weight makes with the common normal is theta. Second, we know that the component of weight along the side in which theta is there, weight से लगा हुआ जो side है उसमें हम weight को का component w cos theta, and the component of weight perpendicular to the theta or along the side perpendicular to the angle which has theta is w sin theta. So that component is w sin theta, that is along x-axis. So w sin theta minus tension is equal to mass times acceleration of the block along x-axis. But the acceleration of the block along x-axis is 0. As the block is tied by a string, it is unable to move in along the incline. So we would say that mg sin theta minus tension is equal to 0, or tension is equal to mg sin theta. So this kind of makes sense. If the block was free to move along x-axis, it had an acceleration g sin theta. And what is tension is doing? Tension is applying a force equal to the force exerted by gravity to prevent that motion altogether. Next, what is the normal reaction acting on the block? So the normal force acting on the block is w cos theta. So we came about this equation from this equation, sum of force along y-axis is equal to mass times acceleration in y direction. So what is the acceleration along y direction? The acceleration along y direction is 0. So all the forces in y direction are the normal force. Normal force is acting along positive direction of y-axis minus the weight cos theta, which is acting along the negative direction. of y-axis. Acceleration along y-axis is 0. So n is equal to mg cos theta. Next we have a question. A block is kept on a smooth surface. A force of 10 Newton acts on the block at an angle 30° with the horizontal. Choose suitable axis and find the net acceleration of the block. Mass of the block is 1 kg. So the question may be a little bit, and you may be unable to see it, but the question is that the block is kept on a horizontal smooth surface, and the weight of the block is given to us. Some force is acting on the block. Force is 10 newtons. So let us draw the horizontal surface. So this is the horizontal surface, and let us say this is our block which we are considering. Now this block is experiencing some force F. This force is acting at an angle, and that angle is given to us as 30°. Mass of the block is given to us, and the surface is smooth. So we are supposed to find the acceleration of the block, and the force of the block is 10 Newton. So what would be our approach in this question? Now the force is acting not horizontally. If it were acting horizontally, we would simply written acceleration as force upon mass. But it is acting at some angle. So by that we mean is that the component of force along the horizontal has to be taken, and we would have to take the components of forces. So let us take the component along the direction in which acceleration is going to happen. So the acceleration is going to happen in x direction. Let us assume that acceleration is going to happen in x direction. So that is marked by A. So our one axis would be the x axis, and the other axis would be the y axis. So we will then write the equation: sum of forces in x direction is equal to mass times acceleration in x direction, and sum of forces in y direction is equal to mass times acceleration in y direction. So let us try a new style of drawing the free body diagram. Let us concentrate the whole mass of the block at some certain single point. That would be the center mass of the block. So this is our block. A force is acting like this. In addition to that, there would be a weight force which would be acting vertically downward, and a normal force acting like this. So normal force would be acting away from the surface. So this angle, the angle at which the force is acting is the angle 30°. So we'll be taking the component of this force along this angle. So this component is of F cos 30°. As we know that the component of a vector along the side in which theta is there is F cos theta, and this component would be F sin 30°. So let us consider the x-axis. So the force acting along x-axis F cos 30° is equal to mass, that is 1 kg, into acceleration, that is not known. Force is 10. Cos 30 is square root 3 by 2 is equal to acceleration. So that means the acceleration of the block would be some 5 root 3 meters per second square. So that gives us the answer to our question. And now let us investigate what is happening in y direction. So there is a force F sin 30°, let's say F sin theta, plus normal force minus the weight of the block mg is equal to MAY. F sine theta is 5 newtons plus normal reaction some N minus the weight of the block, which is 10 newtons. That is equal to mg, or mass time, that is equal to MAY. So this gives us N minus 5 is equal to MAY. So as we know that the upward force acting on the block F sine 30 degree is trying to pull the block in upward direction. The F cos 30 degree force was able to pull the block in rightward direction, in x-axis direction. That's why there was some acceleration. But what y direction? Would the block fly off the surface? So a block would fly off the surface if the force which is lifting the block is greater than the weight of the block, and in that scenario the normal reaction of the block would be 0. So what we have to learn here is that whenever we are thinking about cases when you have to lift a block, then you have to assume that normal reaction is 0, and then we think that okay, there is some acceleration of the block in y direction. But as we know here, in this particular case, that the component of force in vertical direction is not greater than the weight of the block, so it is unable to pull the block off the surface. So simply there would be no acceleration in y direction, so this would be 0, or the normal force acting on the block would be some 5 newtons. So again, with this 3 short examples, we'll be completing this video, and in the next video we'll be taking more examples from this chapter. So thank you for joining.